Good morning, one and all. Myself, Tanaji Srimanta Fartade. I am doing the PhD under the guidance of Dr. Mahesh Kumar Mane Sir, Department of Physics, Shikshan Maharshi Guruvarya, R.G. Shinde Mahavidyalaya, Paranda. My research center name is Sri Krishna Mahavidyalaya, Gunjoti. My roll number of paper 1 is 143 and roll number of paper 2 is 03. Today I am going to present my coursework presentation on the topic magnetic coupling in composites of hard soft magnetic materials. This is the coursework presentation which I am going to present today. Content of my presentation is introduction, analysis of results, synthesis of material, plan made for an investigation, books used for research, journal referred for research, next step of an investigation. These are the points which I am going to discuss today. Introduction. What does mean by ferrites? Ferrites are ceramic compound consisting of mixed oxide of iron and one or more metal which has ferromagnetic properties. Uses of ferrites. Where ferrites are used? Ferrite used in antenna. Ferrite concentrate the magnetic component of radio wave through the pick of the coil. Ferrite used in memory chip. It is also called as the core where each wire threaded through the core serve as transfer winding. Three or four wire pass through each core and used in a magnetic chips. Ferrite is also used in transformer core due to its properties of high magnetic permeability coupled with low electrical conductivity. Ferrites used in high density magnetic recording. Why? So due to its magnetic and average resistance properties. Ferrites used in transducer. What do you know? What does it mean by transducer? So transducer is any device which convert one form of energy into readable signal. Ferrites also used in activator. Activation of peroxymonosulfate (PMS) by spinel ferrite and their composite in degradation of organic pollutant. Spinel ferrite means what? The spinel ferrites are mixed valence oxide where oxygen anion form a closed packed cubic array while metallic cation occupy randomly 1/8 of octahedral side and 1/2 of octahedral intrinsic space. Ferrites used in microwave and computer technology. This is one of the most used of these ferrites due to its properties of high magnetic permeability coupled with low electrical conductivity. Ferrites also used in magnetic resonance imaging, that is called MRI. Due to its magnetic anisotropy property, mainly manganese dope ferrites are used. Doping is the process of introducing impurities to a base material in order to impart desirable properties. Ferrites used in humidity sensors or gas sensors require focusing mainly on their electrical properties rather than magnetic properties. Ferrites also used in photonics. What does it mean photonics? Photonics is the physical science and application of the light photon, that is called photon generation, detection and manipulation through emission and transmission. Nanophotonics or nano-optics is a part of nanotechnology that investigate the behavior of light on nanometer scale as well as interactions of nanometer size objects with light. Electronics. Electronics branch of physics that deal with the emission, behavior and effect of electrons and with electronic devices. Improving display screen on electronic devices. Nanomedicine. So nanomedicine is holding promising changes in clinical practice by the introduction of novel medicine for both diagnosis and treatment. The ferrites are classified into main two types, that is called hard M type hexaferrite and soft spinel ferrite. What does it by soft ferrites? Soft ferrites magnets are those that have low corrosivity So what does it mean by corrosivity? So corrosivity is a measurement of a magnetic material ability to withstand external magnetic forces without becoming demagnetized. Examples: spinel ferrite, garnet ferrite, and lithium. What does it mean by hard ferrite? Hard ferrite magnets are those that have high corrosivity. Example: hexaferrite, orthoferrite, strontium, and barium. Now today I am going to do the presentation on whatever I have completed research work on the topic magnetic coupling in composites of hard soft magnetic material. In this presentation, I have given in detail about my research work that I have done till today. I have completed analysis of data, synthesis of material, characterization of material, and result obtained from characterization of data, and its brief summary has been given in this presentation. Okay, what I am going to do, analysis of the data. In that, sintering and characterization of materials have been done, analysis of results of XRD, VSM, FTIR, SAME, IDAX also were done by me. So for that, which methods I have used? Sol-gel method. What does it mean by sol-gel method? The sol-gel method is a versatile technique used in physics research, particularly in material science and nanotechnology. It involves the conversion of a chemical solution, sol, into gel. It is the conversion of sol into gel, followed by drying and heating to form a solid material. Here a detailed explanation along with a diagram has been given. Sol-gel method in physics. Preparation of sol. The process begins with the preparation of sol, which is stable colloidal suspension of nanoparticle in a liquid medium. These sol contain precursors that will eventually form the desired material. Precursors can be metal alkoxides, metal salt, or organometallic compounds. Hydrolysis and condensation. In the sol, hydrolysis reactions occurs where the precursor molecule react with water, resulting in the formation of metal hydroxides or oxide. This is followed by condensation reaction where the hydrolyzed species undergo further reaction to form polymeric network. Gel formation. As condensation progresses, the sol undergoes gelation. It forms the gel, transforming into three-dimensional network of interconnected particles suspended in the liquid medium. This gel structure traps the solvent within its pore. Drying. The gel is subjected to drying to remove the solvent trapped within its pore. This can be achieved through various methods such as air drying, fridge drying, or superficial drying. During this process, the gel shrinks and consolidates, forming a porous solid structure known as a aerogel. Heat treatment. Depending on the desired properties of the final material, the aerogel may undergo further heat treatment as calcination. Calcination in heating the aerogel at high temperature to induce the crystallization, remove residual organic components, enhance the material properties. This is the diagram of sol-gel method. Now, what is attocombustion? Attocombustion in research science, understanding the phenomena, conditions, researchers study in the condition under which attocombustion occurs. These conditions typically involve combination of factors such as temperature, pressure, and chemical composition. What composition we have taken? Thermodynamics. The thermodynamics of the combustion process are analyzed to understand the energy changes involved in the reaction. This includes studying factors such as enthalpy, entropy, and Gibbs free energy. Second, investigating kinetics, reaction rate. The kinetics of combustion reactions are examined to understand the rate at which atto-ignition occurs. This involves studying factors such as activation energy and reaction mechanism. Rate constant. Researchers determine the rate constant associated with combustion reaction, which provide insight into reaction kinetics. Third, material science perspective. Material perspective, attocombustion is studied in the context of material science to understand how different materials behave under various conditions. These include examining chemical property, structural characteristics, and thermal stability. Characterization techniques. Various techniques such as spectroscopy, microscopy, and thermal analysis are employed to characterize material and analyze their prospectivity of atto-ignition. Safety and application. Safety engineering, understanding atto-combustion helps in identifying potential hazards and developing the safety measurement. Okay, applications. Research in atto-combustion, practical applications fields such as engine design, combustion process, safety engineering, and material development. This is the diagram of atto-combustion method. And last third method is co-precipitation method. The co-precipitation method is widely used technique in physical research, particularly in material science and nanotechnology. It involves the simultaneous precipitation two or more components from solution to form a solid material. Here is detailed explanation along with diagram has been given. Co-precipitation method in physics research. Precursor preparation. The process begins with preparation of solution containing precursor compound of desired material. These precursors can be metal salt, oxide, or hydroxide dissolved in solvent. Mixing. The precursor solution is mixed through lead to ensure homogeneity. This step is crucial for achieving uniform distribution of the component in final precipitate. Precipitation. A precipitating agent such as base or another receiving compound is added to the precursor solution under control condition, that is for temperature or pH. This leads to simultaneous precipitation of component in insoluble compound or solid phase. Formation of precipitate. The precipitated solid form a fine particle suspended in the solution. These particles may undergo further growth and aggregation depending on the reaction condition. Filtration and washing. The precipitate is separated from solution using filtrate techniques. Washing with solvent or water help remove impurities and residual reactant from precipitate. Drying. The washed precipitate is dried to remove any remaining solvent or water. This can be this can be done using methods such as air drying, vacuum drying, or oven drying. Calcination. Depending on the desired properties of final material, the derived precipitate may undergo further heat treatment, that is called calcination. Calcination helps to enhance crystallinity, remove organic residues, and improve material stability. Diagram of co-precipitation method is given here. This is the diagram of co-precipitation method. Now I have done the synthesis using this method, that is called solid atto-combustion method. This is synthesis of material. This is a diagram of. This is the synthesis of soft ferrite which I have done in the lab. Okay, this is the synthesis of hard ferrite. These are the powder bottle which I have used to put powder in that bottle. Now what plan I have made for investigation? So the sintering and characterization of materials have been done by me. Graphs were drawn for each characterization and analysis of data has been done. These are the graphs of XRD analysis. You can see these graphs. Okay. The work which I have done on that work, I have got this result of XRD analysis. You can see here. This is the graph of 2 theta versus intensity. Okay, graph of XRD. Okay, this is the second graph which I have drawn here. This is the graph of FTI analysis, FTI technique. This is the graph of VSM analysis. VSM technique have been done by me. This is the graph of same analysis, same particle size versus count. Graph of EDAX analysis. You can see here. Graph of EDAX analysis. Okay. These are the different images by EDAX technique. Graph of EDAX analysis. For this work, I have used following books: Fundamentals of Research Methodology by Subhojit Banerjee, Kitab Mahal; Magnetic Ferrite, that is called Carlo Apino, Fausto Florio and Pasquin. For research methodology, I have used Fundamental of Research Methodology, Yogesh Kumar Singh. And for hermeneutic material, I have used Perspective to JMD Coe. Journal which I use for the research till today, that is called Arabian Journal of Chemistry, Digest Journal of Nanoparticle and Biostructure, Processing and Applications of Ceramics International, Journal of Alloys and Compound, AIP Publishing. And the last step of my investigation is that in a future, I want to take more characterization techniques results have to be analyzed, and paper writing will have to be started in future. Thank you.